Let's hide everything. Now we have some foam particles. Here they start. Now we have interesting form of foams. Actually, they are shaping what we expect to see. Now let's see these lines. They are so regular and they are nice, but sometimes we don't need them to be that regular. To change them, we have two ways. One of the ways is to go to the parameters here. There's this stringiness, which basically create these filaments shape of water, which if I will decrease from it was 1, can go to 0.8 to create really not regular shape. And at the same time, in the domain itself, we can increase the verticity boost, means that we will create some kind of swirls in the domain itself. And because the foam particles are attached to the domain to a certain degree, as you can see here, min friction and max friction, that means they will be moving exactly like it's moving, with a little allowance for just them to move freely. I didn't limit their age here because I want them to just stay. And if we will just show the splash particles and the dump particles here as example, we'll have really interesting. Remember, this is so very low resolution. The only thing which I think I need to change is the dump particles. For the dump particles, it's just concentrated a lot here. That's because, as I mentioned before, if we will go here, this number is so high, and whenever we increase this number, the amount of particles will be high, but we will face another problem. They will be in clusters or accumulated in certain areas, which we don't like. So I would rather to go 0.14 and create more allowance, like increasing this number to 100 as example, decreasing this number into 0.1 or 1 at least to allow more particles to be created here, this 1 to 1. And also I can just increase this number, can put as example 1.5 million. That way we will keep shape right, not just clumped like this, and it will create a lot of particles. Also, we can change this number, the angle variation. If I will increase this number, actually I will allow the particles to have more areas to move, like here also, but I will just not change these now. We'll change them later. Based on what we have now, I can just do very little changes and get a more interesting shape of water. How can I do that? Let's just see the ocean force. We have very regular wave, if you notice here. It's interesting, but it's just really very regular. So I can go here and change some parameters. As example, the wind direction, I can reduce it to minus 245 as example. So it's not just one direction like this. Also for the wind alignment, remember I eliminated all the waves which are not with the same direction of the main wave. So I can reduce this into 15 as example, which allows other particles, other waves to be created. I can increase this number, just put 2, means that I tilted or put 2 patterns of the wave beside each other. Other than that, I can change these numbers, but I will leave them as they are now. This is first. The second thing is the domain. I can increase this number. I will leave it as it is for now, which is the verticity, which create swirls. But I can increase or decrease this number to create more particles. Actually, I don't need to do that now because we will do this operation later. We'll increase this number much more than this. Decrease it to increase the amount of particles. For now, I will leave it as it is to speed up things. And other than that, we change here what we need to change for the splash. And for this one, I would say I don't need much of particles here. I can reduce this number to 2.2 as example. And because we reduce this number, we will create a little amount of particles, so I can increase this number to 1 million. That's what I need to do. And another thing which is so you will see that it's so important to do. Usually we start from nothing, then we start seeing everything, but it's not realistic. I don't want to start from nothing. Let's start from really interesting frame. Like as example, let's start from here, which is really nice. So what I can do is that I can save this state. I can go to domain and activate this one and make initial state. Also, I can go to the foam, do the same. And for the splash, I will do the same. And for the dumb particles, also the same. If you will go here to open folder or project folder, if you will go to initial state here, you will find that I saved the domain, which is saved in two formats, VDB and RBC, and I saved all the other particles as initial state. Now what I can do is that I can just simply go here and activate reset to initial state. If I will press this, I will be at 0 with this shape. Now I start simulating everything from here. What I will do now is that I will move everything into inactive. I will resimulate the domain itself. Then I will put this on cache and start simulating the other things. And let's start and see some interesting results. Maybe I have to increase this a little, decrease it. So let's say 0.25, just to see something interesting more. And I will reset everything. I will simulate and come back after I finish. Now we finished the simulation and we can just try to see what's happening. I did a few changes, and basically the changes are here, as example here in the foam, because we have these lines, the filaments lines. I reduced this number to create some less lines. Also in the foam, I reduced the age, so it's between 4 and 6 seconds, the life for each particles. And for the splash, I changed this into 2 millions to create more. And in the same time, just kept everything else as it is. If you have anything different, you can see here. For dumb particles, I changed many things, but basically here I reduced this into 0.12. It was 0.14, just to reduce the clumpness. Here I increased the amount of particles. So, and also here, if you remember, I had to change a little the ocean force into these numbers. Nothing really serious. So if we will go now and see the main wave, if you notice, just by introducing more randomization for the wave direction, we reduce the amount of big waves. Even I increase the strength, but still it's not as strong as it should be. So here you can find things more interesting, but less waves. The amount of water is a little, and also you can fill more water here or increase the resolution. Other than that, let's see the splash. You have a good amount of particles for the splash. Remember all this drop. We don't have continuous lines because we have really low resolution domain here. Just from the place which has really more speed and curvature. For the dump, I increase it really well. It's a lot. But if we mix the two together, it will give us something interesting. Again, it's clumpy. We can reduce this number into 0.1 as example, and less clumpy. But again, because we have really low resolution, we have this shape. Let's see the foam alone. The lines are not that obvious now. They are less because we changed the stringiness. That's it. If we will display everything together, I will just display the splash and the foam. Hybrid splash. That's interesting. If I will display all of them, it will be a white. Now all we need to do if we like the result is to go and increase the hybrid resolution. Look at this, this is nice. So other than that, we can just discuss the meshing and introduce some meshing methods. Let's do that, and then we can add some displacement. I think we are ready to do the final simulation. So what we will do, I will go back to the settings before the last simulation, just to make sure that even sometimes it's not interesting, it looks not interesting. When you increase the resolution, you'll see really interesting patterns. I want to prove that by initiating another simulation, which is very high resolution. Let's say high resolution simulation, and I will bring back the same numbers we had before the last simulation. So for the foam, again, I will put 60,000 and I will put these numbers. Again, I will bring this into 1. I don't want to change that stinginess. I need these lines. I like it. Other than that, for the splash, I have 700,000, the same number, the previous number, 0.11, and they live 3 to 4.5 seconds. For the dump, 1 million, 0.14. Now we will have more particles for the water body, or the simulation, the domain means that we will have continuous shape for the dump particles. So that's it. I think everything is ready now. I added this one, which is a volume killer, by going here, add, daemon, and a volume killer. The idea about this is that anything happens outside of this box will be deleted. So I don't need the particles, which sometimes some of the particles will go out. Remember that I have already this to contain everything inside. So actually I don't need this, but just, to have an idea, if I don't have it, I can just do volume. Else, nothing. I even brought this to the same previous numbers. And I'm ready to do the final simulation. But before we do the final simulation, let's do one important thing. Let's create some displacement. As you remember, we talk about having some small details, some small displacement details on the water body or the mesh. And it's preferred to do that before we do the meshing, before we do even the simulation. So in the domain, we have a layout, which is this one, ocean statistical spectrum, which basically all about the displacement. Let's see how we can create really interesting displacement for the water. So to put a suitable displacement here, which way shows the small waves or the small details on the water surface, we have many methods to do that. One of them is to use the shader of the mesh, which we can create now and see how it will show us how to do the displacement. Another way is to use the real wave to create that details. So what I can do is that I can create a real wave surface. First, I don't want to load anything here. So basically I just will deactivate this. I don't have anything simulated yet, but just to make sure I have the first frame for the domain, I don't want it to load. Means if I will scrap the timeline, it will be easy for me to see everything because I'm not loading anything faster. So we will click here and we will have this surface, and I can just rescale it to be almost as big as the domain itself. Can bring it here. It's important to have it as big as the domain. That's good. Just remember, this is how everything should appear. I will hide this mesh. I don't need to see it. So the land, and I will hide the volume. Even the rocks, I don't need to see them. The only thing I need to see is the real wave. As you can see, it's a big mesh, but the idea about this mesh is that it can show us some very interesting displacement and ripples. So what we will do here is that we will start putting some numbers and trying some numbers, and based on that we will, if we like the numbers, we will transfer them totally to the domain because we have the same basic setting. To create these numbers, the first thing I should just go to 0, reset everything. Then I can right mouse button here and I can add wave, and in this case ocean statistical spectrum, which is exactly the same one we have here, ocean statistical spectrum. And in that one we have some settings which we saw some of them during our study for the ocean force, but there are some differences we have to take in consideration. So as soon as we put this one, let's just reset everything again. We already have something interesting. I can just press 9 on the keyboard and I have this wave, which is really nice. But let's change a few settings and see how everything is changing based on that. So as example, the weight or the time scale, I can increase this. Anyway, I can't see any animation here except if I will do some simulation. Let's try do some simulation and it will be fast. I will stop here. You can see that we have small movement, which can give us an idea about the wave we're gonna get. So it's not just the shape, even we need to know the direction of the wind, how everything is moving. Because of that, I will go back to 0 and we'll start putting some numbers. The depth, we explained this before. Basically, with more deep water, we will have certain kind of waves. And if it's shallow, the wave's gonna just always become smaller and just decrease. For the vertical scale, it's how high is the wave. This number is totally connected with the dimensions. Means if I will increase this, or this. It doesn't matter if I will increase one of them, I keep the other. They both connected to each other. So as example, if I will go here to 0.1, let's reset everything. This is crazy. As you can see, the wave is so high now, but that basically related to the dimensions, the scene dimensions. As we mentioned, let's imagine that this describe how big is the wave. So 500 is big. Let's go to, as example, 20 and reset everything. Now we can see that it's like almost we have no height at all. Means that with a smaller area of sea, I will increase this into 100. I will start seeing really more. So let's see, 35. Now you can see something. I can bring that again to 0.4, bring that to 100 and see what we'll get. This is interesting. And we can simulate that to see how is the movement. Remember the time is 1. It can change that. But let's see how the movement is happening, and based on that we will know if we need to change the time factor or not. I will stop the record and come back when we have more frames. This is good. I can stop the simulation and we can just look here to see how is everything moving. You can also go to playback and run OpenGL window, which gonna basically do some video. This is a big scale video. I can reduce the scale by going here to open preview preferences, and here I don't need to do HD. I can go to 720. That's good. Now when I do playback OpenGL, it will be smaller, faster. You can press escape button whenever you want and it will display everything. This is very high wave. This is the first thing we notice. The direction is, this is it, and it's a little random. In the same time, we have an idea about what's happening here. In terms of time, I think the time factor 1 is good because this is a small kind of wave. It should be small kind of waves. Let's stop this and let's change the numbers. So the first thing, the resolution. I will not change this thing because it just matches the resolution here in the ocean factor force. But usually I work with 512. Let's keep it small. Now for the depth, I will leave it 200. And for the vertical, I will go to 1. 0.1, sorry. For the dimension, we can, as mentioned before, if you remember, it was 27 meters like this. So I will just put 27 meters. I can put 25 meters, 27 meters, the actual dimension. For the wind speed, we can really decrease the wind speed. Let's put 1 and see if that will be good. Then according to that, we will change. For the direction, I need it to be in that direction. So let's see. Now we can't see any details. Maybe let's increase it here a little too. We can see some details. but I don't really need much of details here. But let's go down and change few other things. As example, we can go to the level with details. Let's reduce it really more. I can see it more now. And maybe if we will increase this into 512, we'll see more details. True, just a little. For this number, I can put whatever I need here. It's just a random number. Let's just put anything. For the choppiness, it's just basically increase the sharpness of the waves. So I can keep it as it is, or I can just change it to number and see if that will work with us. For the U and V, if you remember, we had V2. I will do the same here, not for any reason, just to make sure that we have at least the similar numbers. So this is nice. I don't need more details than this. And as you notice here, we can't really see details. It's just a low resolution. I can choose it, go to real wave, and here the polygon size, I can reduce it to half as example, reset again. I can see the waves much better. So what we can do now is we can just keep this like that and go here and change this into 5 as example. Reset again to see the shape. Now we have something interesting, but again, we can get better result. Can go to 512 again. Just a little enhancement, not much. If I will increase this into 50, we have much more defined waves, which I don't like much. All we need to add is just small details. So again, we can transfer all these values into the displacement here in the domain. The only thing which should change is this one, the vertical scale. Usually it's 10 times to 100 times smaller than the vertical scale here. So let's take that in consideration. What we can do is we can go to domain. Let's just deactivate this and hide it. And in the domain here, we can activate this. Let's put it always. Time factor, I will not change it. Quality, I will keep it 512. Vertical scale, as we saw, it was 5. I can go 0.5, but also I can go 0.1. Let's start by this because the value should be 1 to 10 to 1 to 100 of the real wave values. For the dimension, 27. For the wind, if you remember, we bought just 1. For the wind direction, it was 180 because we want to make sure that we have the same movement direction. For the wind alignment, I will leave it as it is. For the minimum wave, it's 0.02. We'll leave it as it is. The same seed, this is the same. And here we decrease this into 0.4. We will activate white cap channel and you will see how that will work with us. Basically, we will not be able to export it, but just we will see how we can use it. And for UV, I will just put the V2. So now we have all the settings we need and we are ready to go and run the simulation and see how everything gonna be here in the domain. Before we run the simulation, one very important thing, of course, we have to put it on green means it's active, and we can go to the export, which which is the most important thing before we start simulating, because if you will forget this step, we will end up having nothing. So for the hybrido itself, the domain, I don't care about the emitter. For the domain, I need to export these to, they come by default. We can export them by default. And for the texture, sometimes I need to use this displacement texture in 3D program, but in this case, we will not use it. We will actually bake it, as you will see on the mesh, and we'll have the mesh with the displacement later in 3D program. I can export all the particles as BRT, but again, I don't have anything to do with the particles here. The particles which I want to export are these particles. So here I need to check Krakatoa BRT, and this by default is checked. Why BRT? Because we want to render using Krakatoa. So it will export the position, the velocity, force, age, normal, radius, ID, and mass for each particle, which is so good if we want to manipulate the particles later. For the dumb particles again, and for the finally the foam. So to activate these, all we need to do is to run the simulation, and they will be saved on the hard and the project files automatically. Now, before we continue to simulation, I already simulated the first frame from the domain. So I can go to 0 and I will show the timeline, jump to the first frame. Let's show this one. It will take a little time because it's a huge amount of particles. Now let's show the rocks. Remember, the rocks were here. How many particles we have? We have almost 6 million particles, which is not much, just good amount. And here we can build up the mesh and see how everything can be applied, how the displacement can be applied to the mesh. But also let's see another thing before we jump into the simulation and the mesh, which if I will create a new mesh here, sorry, it's clipped, so I can go to add mesh and create one of the hybrido meshes. I can create this mesh. It's automatically taking into consideration the only domain in the scene. Let's discuss a few parameters here. One of them is the weight normalization, because basically it's present the mesh in a better way in areas which we have, jumping particles. It's not a replacement, or it will not be good if we don't have much particles. So it's just work with a good amount of particles for the weight normalization. Good presentation for the mesh. For the auto polygon size, usually I say off. These numbers, it's preferred to have equal numbers to speed up the simulation, but in general, this is the polygon size. After all, we will have mesh and we will have the smallest size for its polygons. This is the smallest size. And here the radio, every particle will have around it one sphere, let's say metasphere. And beside each other, they will accumulate and form the mesh. This is the radio of every one of these spheres. Of course, the radio cannot be smaller than the polygon size, but I can put both of them equal. So that will be the fastest way. Open boundaries, if I want to cut the mesh from here and I don't want the mesh down, I can use the icon here to position the icon to make sure that everything outside the icon is cut. We will use another way for this, just to demonstrate all the possibilities. But for now, let's jump to extension. If we will activate this one, we will have the opportunity to activate this one. Extension means it will extend all the mesh to present a big surface of water. We will not use it now. Let's go down here for displacement. If I want to take all these settings in the domain into the mesh, I need to activate this. And when I activate this, I have this automatically activated, which if I want, I can deactivate it and change the edge length. Remember, we have here the polygon size, but for this, it defines when I will add the details, I need really bigger mesh. Let's say more detailed mesh. And sometimes it's not as detailed as I want, so I can decrease this amount and I will have more detailed mesh. But for now, I'll just put it auto. It does a good job. For the height attenuation, speed attenuation, splash attenuation, verticity attenuation, these parameters are important actually, but I tend to not use any of these because it's buggy. Until now, I can't really be sure that you will have a good result using these. What they will do, if I will have a wave which is high or splash or anything, I can activate this as example. The displacement will be applied on all the surface, but I don't want the displacement actually to be applied on the high places because it should be like smooth, you know. When you have some waves or some splashes, it doesn't have displacement, doesn't have waves actually, small waves. So that will prevent the waves from coming to the splash. It will attenuate it. Also, if the particles or the mesh in areas which is very fast, sometimes it doesn't have waves. That's where I can just deactivate the waves or the displacement. All these will deactivate the displacement in the associated property or attribute. Speed, whenever the wave is high, the displacement will be less. But again, as you will see, we will not need to activate those. Now we have the filters, and we will go into that in details. But let's now do one thing. I can go down here. Let's build the mesh. Just by pressing right mouse button and press build. It's working. As you can see here, the displacement is so deep and we have a lot of details. Let's hide the domain. And also we have huge amount of faces. We have almost 4,300,000. What we can do is we can go to the domain again and reduce the vertical scale to 0.02 as example. And also we can make it bigger. So we can play with the dimension. If I will choose 50 as example and remesh everything, we have this now. Let's do the opposite by going to the domain and decrease this into 15 as example and remesh again. I think this is suitable more. I will keep these settings, but let's see now we have the displacement. Let's uncheck the displacement and try to remesh things. Remember, we have 4 million and almost 300,000. Now, because we uncheck the displacement, it will not auto edge length. So means it will not add more details to the mesh to be able to present or to show the displacement. And we will see that we have almost 500,000 face or 600,000 faces. But also we can see that it looks like we have some displacement. Actually, we don't have displacement. This is due to the settings here. If we will increase the value for the radio, it will be covering some of these gaps, but because we have really small particle radius. But we have another way of solving this problem, which if we will see filters is a very good place to work things. So we have filters for the splash, which we will see after we simulate everything. And we have some splash to show. And we have filter for the core. If I will activate this one, I have two parameters. Of course, the global, it will do thinning and smoothness for everything. I tend not to use this thing because I need to take care of both areas separately. But we have this factor. Basically, this factor is a unitless factor, and it defines for each point of the mesh if it's a core or a splash. The difference between the two is the core of the mesh is the core or the inner part of the mesh, which is not above the mesh surface like the splash. The splash is area which has more displaced position. So this factor or this number defines if the point is belonging to the core or not. So if it's less than this number, means it will not take in consideration as a core. Then it will not really smooth it with this amount of smoothness. This is 128. We can reduce it to 64 or another number, but it's express how much we have smoothness. Let's rebuild the mesh and see all these artifacts, I would say, gonna show. Of course, there is another way to treat this, which is increasing the particle radio, but also if we will increase this, it will affect the total shape of the mesh because it will be bulky or bulby more. Now we have everything smooth, so good. If we will now go to the domain, activate, or the mesh, activate the displacement, and remesh everything again with the smoothness, we will have the displacement on a clean background, which is gonna show us the actual displacement. Let's wait a little. This is the actual displacement. As we can see, it's much nicer. Now, the final thing I wanna do is I will try to visualize this the other way. So we used RealWave to transfer some numbers here to the domain. Do we have other option? Actually, we have. If we will go down here in the mesh and to the shader area, I can go to displacement. If I will activate displacement, I will have some displacement visualization. And it's another way to see how everything can be seen directly on the viewport. I tend to use the RealWave because it's just more honest in transferring the information. But to see everything, you have to press 9 or 0 on the viewport first. And in the same time, you can go to the domain here and change some numbers. Let's put sharpness to 0 and let's increase this to 0.1 as example, and see direct feedback. If I will put this to 5, direct feedback 0.1. If I put it to 500, so it will be really giving us information about how everything is gonna appear. I can reduce this to 0.01 and I will have just very small amount of displacement. Again, I tend to use RealWave, and that's the technique we're going to use also with the whale. And just for you to understand that we have another way, which is this way. So I will go to the mesh again and I will hide the shader because I don't need to see it. In the domain, I will make sure that I have the same numbers again, 0.02. And for the sharpness, 0.4. That's it. Now I will do simulate everything, including foam, splash 1 and splash 2 dump, and the mesh and the domain in high resolution. Then I will come back to do a final enhancements and to take in consideration some of the smoothness for the mesh for the splash areas, as well as the position of the foam particles after the displacement. We did simulate everything and it takes some time, but I need to know two things. One of them is that if you remember the previous one, which is the low resolution copy, we simulated until like 150 frames or 160. Then we choose a frame which is interesting, which has interesting wave, and we save that frame as initial state. Then I change the resolution before I simulate again. You can't change the resolution. So if you have the domain and you simulated everything with this resolution or this cell size, then you choose a frame which is interesting and you go here and save the initial state. When you go to 0, you can just change the number and start the simulation again. RealFlow will require the same value here. I needed to mention that. Also, in some situations like this with the high resolution, with everything, with collision here, I tend to increase the hybrido substeps at least 2 here, 1 by 2 or 2 by 2 or 2 by 3, based on the situation. That will allow me to make sure that no problem is going to happen. But in general, we have now some frames and I can show you what we have. The main water body, let's go to, as example, 90. You can see the particles here. We are displaying the splash 1 also. So now you can see that it's interesting really. When you simulate with huge amount of particles, you start seeing some good and interesting patterns. Then I can do some playback, but let's see other particles like the foam. And here is the splash 1. And let's see how much splash we have. We have 1,156,000. And for the foam, how much? We have 24 millions for the foam. That's why I think when we render the foam going to be really interesting, because it will be real, exactly like we see in big scale oceans. Also, we have really interesting splash here on the rock. Let's see the other one, which is the dumb particles. As you can see, it's just dusty. And also the number is 20. The number is just 800,043. We didn't make much of this, but also I'm not displaying everything. If I go to here to display, I'm displaying just 20% of the particles. I can do that, of course. And also you can do that in the 3D program. You can render a part of them because you will import them in BRT importer for Krakatoa, as we will see with the whale project. But let's go now and hide the domain and display the mesh. Remember that we have to, let's go to some frame. Remember that we have to save all these before we start simulation, as mentioned before. And one of the things we have to save is the mesh. In this tutorial or in this course, I am saving the mesh as a Limbic file. We will see that after we see the mesh. For some reason, I renamed the mesh. So let's go here to the folder files and see the meshes. We have mesh 1. And as you can see, I saved them as a Limbic file, ABC. So let's change its name to mesh 1. That way we can make sure that we are importing the mesh. And let's jump to any frame we need, as example here. I enhanced or made the displacement bigger, as you can see, but this is the mesh. And here I just activated also the thinning. for the splash. So I have two thinnings for the core and for the splash. The values here again, this is a unitless number, and in the same way here, it defines if any point of the mesh is splash or not. So here I'm taking all the points of the mesh which are considered as splash in a percentage of more than 80%. Usually I go to 0.4 and 0.2 here, and that would be the result. As you can see, we have good representation for the details. We can go with other settings, of course, we can change the settings, but this is what we have, and I think it's good. Let's go to some frame which has no mesh. I didn't create all the mesh all the way, and try something. Actually, we have the mesh. Anyway, so here I don't have the mesh, yeah, 52. Anyway, so if we will jump to a frame like 100 or 90, let's say 90, 91, and let's display also the foam. We have the foam now and we have the mesh, but let's just go and see here. As you can see here, some of the particles are under the mesh, as well here and here. This is strange. Here also. And to see that, I can just show the mesh. Look, all these particles should be above the mesh, not under the mesh, because they are not bubbles, they are particles. But why they are under the mesh? Because of the displacement. So that's an issue. If we will render everything from certain angle, we will have some of the particles under the mesh. Two things to take in consideration. One of them is that the mesh will be transparent because this is a C. So when we render everything, we will render the particles alone and the mesh alone, and basically we should see the particles from the mesh. If we will render one pass, two passes, I prefer to put the particles above the mesh. This is one consideration which we can deal like in a simple way. Another way is when we will render with BRT or with Krakatoa, we will do one thing. We will render the particles above and the particles under the mesh, and actually we will shade them differently and they will look really nice. But is that a solution? It's a simple solution. It's not actual and serious solution. The serious solution is to go here to Hybrido. We have tools to fix this. One of them is display foam particle sequence, and the other one is snap foam particle sequence. This one is the one we need to know more about. So if you will just go here and try to read, you will see that it will snap the particles above the mesh. And basically what we need to do is to catch the mesh. So let's run it. I will select the mesh, then I will select the foam, and let's see what's gonna happen. Actually, RealFlow will create another foam system. It will save it in the same location as we have the foam, and it will call it like foam snap or something. Let's run it. This is working in a sequence, so it will start working for several frames. Let's wait a little. Look, we created here hybrid foam snap, which is a new system which has particles, and basically all the particles inside this node are above the surface. As you can see, some of the particles here are above the surface already. So let's see here now, and we have all the particles snapped above the mesh. Let's make sure. Actually, yes. And if we will go to the object or project folder, we'll go to the particles, and the particles, let's go to RPC. And here I should go to the newly created particles for the foam. Here I have the 91. Basically, this is a new particle system or a new frame of the particles which is snapped above the surface of the water. If we will do everything like I did here, 100, 101, 102, basically we'll have all the particles, another sequence of the particles above the surface of this mesh, which is exactly what we want. That means we came to the minute we say that we finished this section. But let me just concentrate on two things. Let's go to export, and in export we can go to mesh, and in mesh I exported everything as ABC. If you remember, ABC will export all these parameters. Mostly I will not use this or this or this. I may use the velocity for the motion blur, and later we'll import all the meshes using a V-Ray proxy, which is the best way to handle velocity. Else, I would prefer to go with bin because we don't have to convert it into sequence. Converting ABC into sequence has some issues we will deal with during our work on the whale project. Other than that, I think we covered everything related to how to create a sequence of meshes, particles, snap particles, and at the same time how to order things. Now the mesh, if you look here, it's trimmed. And what I can do always is that I can use the domain icon to do the trimming. But also I can do another thing, which I can create a box like this, box 1. And if you notice this box, if I will go to wireframe, this box is intersecting with the mesh in certain area, here and down. Of course, I don't want it to intersect with this area because I need the mesh to slide here and to show a correct reflection. But in areas like here, which is deep enough, sometimes I don't need to have all these faces, especially that I have displacement, because the displacement, as you will see here, is projected on the mesh top projection, means it has displacement here and down. That way we need to get rid of these faces. The best way to do it is to customize a shape or object like this, and we go to the mesh, and in the mesh we can choose clipping object and choose the box. When we choose the box, we have the option to say inside or outside. So inside means that everything inside it will be available, and everything outside the box or trimmed by the box will be cut. That's why I have less amount of faces. It was 600 and something. Now I have some 500 and something. So that's it. Thank you for watching this section, and I will move to main scene of the whale jump, and there we will go through all the things we went through here in details. In the same time, we will have to deal with a more complicated system or scene.